This is part 3 of section 3.1, and we're going to talk about annually compounding interest. So here, if P is the principal, R is the annual interest rate as a decimal, T is time in years, A is the amount of the investment after T years. So this isn't just going to give me the interest like the simple interest formula did. This is going to give me the total amount at the end. So as for the interest, simple interest, we got the interest first and then had to add. On the compound interest formulas, we're going to get this amount first, and then we'll find the interest by subtracting instead. Okay? So this formula is A equals P times 1 plus R to the T power. So Juanita deposits $8,000 in a bank at the interest rate of 7.5%, compounded annually for 5 years. How much will she have in her account after 5 years? So just plug everything in here. We're looking for A. A is equal to the principal, which is $8,000, times 1 plus the rate, which is 0.075, raised to the T times 5 years. Double check your unit here. So that's what we have. And then plug this into your calculator. You're not likely to get an exact answer, so they will want you to round it to the nearest cent. And this is approximately $11,485.30. Now, how much interest will she receive? Well, you take the amount after 5 years and subtract away your principal, what you started off with. So you get $3,485.03. Okay, so this is if you are investing, if it's compounded only once a year. Now, of course, we do have options that are compounded more often than that. Okay, so let's look at our more specific, our more general compound interest formula. Now, it looks like this. A is equal to P times 1 plus R over N to the NT. Now, the difference between this and the one we just had is that variable N. N is the number of times interest is compounded per year. So in the previous problem, it was compounded annually, so that meant our N value was 1. And you can see that if you plug in 1 for N here, you get exactly this formula here. So there's no real reason to memorize this formula because this formula will always work. Okay? But really, that's the only big difference. A couple of definitions here. A is also called the future value of the investment. And another name for R, the annual interest rate, is called the nominal rate. So if you see those words, that's exactly what it means. Okay? So I said earlier that when everything else is equal, the more number of times you can compound in a year, the more the future value of the investment is going to be. So you're going to see several problems like this, where you have one major investment, and all they do is to change the number of times you are compounded in 1 year. So you should see as the amount of compounding periods increase, you're going to end up with more and more money. Okay, so since I'm using the same basic thing, what I'm going to do first is I'm going to plug the parts that are always the same into this formula so that I don't have to do that rewrite every time. Okay, so my principal for all of these is going to be $5,000. The rate is always going to be 6.5%. Okay, and my time is 1 year. Okay, so my general formula here, A is equal to the principal times 1 plus the rate as a decimal over n, that's the part that's going to change with each of these, raised to the n times t, but that's 1. So in that case, I don't really need that 1. This is what I'm going to plug into every time. So if I'm asked to find the future value if it's compounded annually, n is the number of times it's compounded in a year, so in this case, my n value will be 1. So I have A is equal to 5,000 times 1 plus, dividing by 1 here, that's the first power as well. So I have 0.065. And in this case, if you do that multiplication, you get an exact answer of $5,325. That's how much that's going to be worth at the end of 1 year. Okay, so all of these increase in order, so I expect every answer I get after this to be more than this. Semi-annually, that means twice a year, so my n value is 2. Plug this in here. Plug it in here, sorry. A is going to be 5,000 times 1 plus 0.065 divided by 2 raised to the second power. If you plug this whole thing in your calculator, be really careful with your parentheses or you can really mess things up, okay? If you do this arithmetic, you'll get approximately, we're going to round to the nearest cent here, $5,330.28. This value is more than this, so it at least makes sense. Now, these shouldn't be dramatically more, but definitely more. Okay? Quarterly, that means 4 times a year. N equals 4. So again, plugging in the same place, this is going to be a 4, that's going to be a 4. So A is equal to 5,000 times 1 plus 0.065 over 4 to the 4th power. And when you do this arithmetic, remember, it should be more than this, but not dramatically so. Your answer is $5,333.01. Okay. Now let's compound monthly. So my n value is 12. A is going to equal 5,000 times 1 plus 0.065 divided by 12 to the 12th power. And again, I should be getting an answer more than this. And this is $5,334.86. And then finally, what if it's compounded daily? Now, I do want to point one thing out here. If you've encountered this before, depending on what context and what textbook you learned it from, you may have a different value for the number of days. In this class with this book, you're going to use 365. Often, for whatever reason, in business, they often use n equal to 360 instead. So if you've used this in the past, not for this book, okay? Although there are valid reasons for using each one. But here, 365, we do not worry about leap days. Okay, so this value is 5,000 times 1 plus 0.065 divided by 365 to the 365th power. And this value will be $5,335.76. Again, more than this one, but not dramatically so.